start on our next step, which is creating the jumping script. So let's create a new script, call it player jump, open it up in our Visual Studio. We're back to our empty script file, and we're going to start very similarly to the way we did the movement. We're going to import the rigid body component. This time I'm going to start it off by saying private. This means only the player jump can access it within its context. And we're going to rigid body 2D. I'm going to call it rigid body 2D here as well. If it's a private variable, we have the naming scheme of putting an underscore underneath it to signify that. And we're going to get the component like we did before. Next, what we want to do is we're going to create an if statement, checking if the player is clicking a button inside our update method. So we're going to create an if statement, and unlike last time, we're going to check for the actual key press. So we're going to do input dot get key down key code space. This will check if the player is clicking the space button. Now that we know that the player has clicked the button, we're going to update our rigid body, and we're going to do it by updating the velocity. We're going to create a vector 2, and what we're going to do is we're going to get the rigid body's x velocity. That way, if the player is clicking buttons left and right, we're not interrupting it by jumping. And we're going to give it a value. We don't want to have a value here. We want to have a public float that we're going to call jump force. And let's make it equal to 10. That way we can adjust it in our inspector as the game plays. Let's save it and go to our Unity. Let's make sure to attach our script here. You can see that you can adjust the jump force, and let's try it out. So as you can see, the player does jump a fair bit amount. You can see that we're actually going through our platforms. We have that ability to go through the bottom of the platform and land on the top. But here's a problem. You can keep clicking space and the player will just fly off. So we're gonna have to find a way to make sure that the player knows that they're touching the ground and that they're in the air. That way they can't just spam the button and fly off. How do we approach that? First, let's turn off the game. We're gonna go to layers, and we have a ground layer. So we're gonna identify the walls and the floating platforms as ground layers, and this will allow the player to check if they're touching the ground and only then jump away. First, let's go to our grid. Let's look at our floor. We're gonna make sure that this is set as a ground layer, and we're gonna go to our floating platforms and make them a ground layer as well. That way, if the player touches any of these at any point, if the player is touching these, the game will know that the player is able to perform a jump. Next, we're gonna create a new collider. But we're not gonna do it the same way we've been doing it here. We're gonna create it during the game time. So what we need to do is create a object that will sit at the player's feet. It will check if the feet are touching the ground. And then internally, the collider is gonna be calculated to see if they're touching that given type. So let's create a new object. Let's call it feet collider. Let's see where it is. Let's put a little dot on it so we can view it. Make sure that the gizmos are on so you can actually see it. Let's make sure you're in the scene view. Let's go to our player and let's just move the feet collider to be actually at the player's feet. Next, we're gonna have to actually bring this information into our script. We're gonna have two new variables that are gonna be public. First is gonna be transform, and then we're gonna call it feet collider. And next, we're gonna have a public layer mask, and we're gonna call it ground mask. Let's save it. Go back to our Unity. And now you will see that we have two new things we can connect. First, we're gonna drag our feet collider into our feet collider, and then we're gonna choose a mask. We're gonna choose the ground one, and now we can go back to our script and actually create that check. So want to do is we're going to create a boolean called ground check, and we're going to use physics 2D that overlapping capsule. This will create a capsule collider around the feet, and it will check if the player is touching it. As you can see right here, it tells us everything we need to put into it. So first, it's the point. That's going to be our feet collider. Next is the size. We want it to be relatively small, so we can do something like 1 for the width of it and very small for the height. We don't want it to be a very big collider. We want to just when the player's feet are touching the ground. And you gotta place F to indicate that it's a float. Next, we gotta provide it with a capsule direction. So we're gonna do capsule direction that horizontal. That means that the capsule is gonna be laid out horizontally instead of vertically. And then you gotta place the angle, which is gonna be 0. And lastly, we have to define the layer. So we're gonna say ground mask. As you can see, I messed something up. This is supposed to be a vector, so we're gonna pull out the position out of it. So basically right here, what we're doing is we're creating a true or false statement that says create a collider at this position, make it this big, make it lay horizontally at a 0 degree, and check for a ground mask, anything that is called ground. Now, to make sure that it's actually working within here, we're going to expand our if statement by using an and symbol. So right here, these two and signs create a statement saying that this and whatever else I'm going to put here has to be true for this to actually happen. I'm going to type in ground check. And now, only if the player is clicking the space key and they are touching the ground, that the player will be allowed to jump. Let's save it and test it out. As you can see, I can keep clicking space and I only jump once. Doesn't matter if I'm on the ground or on the floating platform. But if you notice, we have a problem in the water. The water is not a physical object. It is a triggerable collider. Therefore, this kind of method of physical checks does not work. We're going to have to come up with a different solution. We're going to do this by working with the tag system. So instead of using the layer, we're going to use the tag. We're going to create a new tag. We're going to call it water. You got to go back and make sure it's applied. And then we can jump back into our script. Right now we only have the ground check. What we want to do is create a water check as well. It's going to be used from a different method. So we're going to make it a global variable. Let's call it do this and water check. And for consistency, let's take the ground check and also make it a global variable so we can keep track of it in the future as well. We're gonna replace it here and here. And we're gonna create a new method that's within the Mana behavior library. It's gonna be called onTriggerEnter. Make sure it's the 2D version, otherwise it won't work. And we're going to create an if statement that checks the collisions tag is equal to water. Make sure it's spelled correctly with the same capitalizations. And we're going to make sure that the water check is true. So when the player enters the water, the check is turned on. And then we're going to create one more method called onTriggerExit, where it's going to do the same thing, but it's going to turn the check off. That means when the player exits, they no longer can jump. Last thing we got to do is modify our checker here. We're going to create parentheses around the checks because we want to make sure that either one of these is true. So we put parentheses because of the pandas. Anything within parentheses gets looked at first. So we're going to do water check. So basically what we're asking here right now is if the player is touching ground or they're inside water, either one of these can be true, it doesn't matter which one, and the player is clicking the space button, then we will jump. Let's save it and test it. So, as before, we can jump around here and here. But now, if we're in the water, we can also jump around. There we go. Now there's a couple things we want to modify for our player. One, we want to change the speed at which the player falls. Currently, the player rises and falls at the same speed. It's fine, but it could be better. We would want to have the speed actually fall much faster than rise. That way the player can get back into action quicker. So let's deal with that. Let's go back to our script. And what we're going to do is we're going to create a new vector. We're going to have a private vector2, and we're going to call it gravity vector. We're going to initialize it in our start function. We're going to do gravity vector, and we're going to make it equal to a new vector where the velocity for x direction is 0, but the velocity for the y direction is physics 2d that gravity y, and make sure it's negative so it goes down. This is defined by Unity's game engine, and you can go into the settings and adjust it, but it should be 9.8, which is the real gravity value. Next, what we're going to do is we're going to check if the rigid body is falling. So we're going to do velocity that y is less than 0. That's when we want to start applying our negative forces to the rigid body. So like before, we're going to do this here, rigid body, that velocity, but we're going to, instead of setting it to be this speed, we're going to actually continuously update it with the bigger value. So what we're going to do is minus equals. That means every frame we're going to subtract more and more, and the velocity is going to get faster and faster. We're going to use our gravity, but we also want to be able to adjust it just like the way we adjust our force of jumping. So we're going to create another public variable, float, and we're going to call it fall force. Let's make it 2. So we're going to multiply this by our fall force. And what we're going to do is we're also going to, as Visual Studio showed us, we're going to use time, that delta time. This basically calculates how much time has passed between each frame. So we're going to calculate 2, or whatever your fall value will be, 2 times this difference of time times the gravity. And we're going to continuously subtract this value until the player is touching the ground. Let's save and test it. As you can see, our player falls down much faster once they start falling. It creates a nicer arc and lets you get back into action much quicker. There's one issue with our jumping system so far. That is when the player is in water and the player is going down, the gravity that we have for jumping also is pushed on the water physics. So what we want to do, it may not be very visible right now. Let's expand. Let's make this rise a bit higher. There you go. As you can see, the player rises much slower than they fall, and we want to preserve the buoyancy physics as the effector should be. So let's go back to our script, and right here we're going to change one thing. We're going to create an end statement, and we're going to make sure that this doesn't happen while the player is inside water. If the player is in water, the gravity should not be pulling the player down as if they were falling. Let's save and try it out. Alright, so let's try it out. As you can see, let's raise the water level again. As you can see, the water is not affected by our falling anymore, and the player can float as intended by the effector. Now there's one more issue that you may notice right now. It's if we run up against the wall, we get stuck on it. We don't want that to happen. We want us to be able to slide off the walls with ease. To deal with that, we will create a physics material. Let's stop our game. Go into the physics material folder, and let's create a 2D physics material. 2D physics material. As you can see, let's call this player. We have bounciness and friction. Right now friction is set to 0.4. Let's set it to 0. We're going to take this physics material and place it in our box collider. Let's test it out. And as you can see, our player is no longer getting stuck on the ledges. Before finishing off this section, I would recommend that you comment your code so you know what's happening and get a better understanding of what we did. But that will be the end of part 2 of the player controls. And next time we're going to create objects that the player can interact with, and we can start designing our levels with them.